RIMES is a relatively new organization established in 2009. It's intergovernmental, owned by and managed by member states in the Asian, Southeast Asian region, and it's registered with the UN under Article of UN. And its major support comes in terms of institutional support initially from the UN SCAP. So RIMES, the full form stands like regional. We have about 32 member and about 20 signed members, collaborating states from Asia and Africa. It's integrated in terms of linking science with the users of science information, here climate and decision makers, and also multi-hazard in terms of dealing with several different hazards. It started with the tsunami which happened, and then around that time when the center was started, and then we moved on to various other hydrometeorological hazards, and then early warning system, because part of it is dealing with all the early warning for extreme weather events, and it is a system which consists of program unit and various other secretariat and so on working together in a collaborative fashion. Most of the members are from the meteorological services, the directors of meteorological services in the respective member countries. So coming back to the title of my talk, it's about operationalization. So basically what we are trying to do is to translate whatever science and technological information on climate which we have into services. And when we say services, we mean that it should be able to influence decision and make a beneficial contribution. So that is the target. And then here again, we must appreciate that the solution needs to be appropriate in a particular setting or context, so that its level of complexity is easily assimilated into that system where you are dealing with, for example, institutions. If you go with a very complex tool, then it's very difficult for them to assimilate it, and it will not become an operational solution. So that is something which we are very careful about. And then scalable to accommodate better technology, like the earlier presentation, where you have, whenever we have some betterment in the scientific understanding, in the model techniques and so on, so we should be able to plug in these developments into the system, and that's what we mean by having it scalable. And there should be a strong institutional connect, so that its operational institutions are well connected, and that takes a lot of time and effort in terms of coordinating, and within the government system it's even more challenging. So then there is a high degree of end user linkage. That means you are linked with the producer of climate information to the ultimate user, and that linkage has to be very strong. And then there should have a clear feedback, so that the improvements are based on this feedback. And of course, there should be standards in the kind of information being provided. It should be authentic, accountability should be there, and confidence. So with all that, we have talked a lot this morning also about agriculture is, as we know, already an effort which involves minimizing impacts of adverse climate and maximizing the favorable periods. So this has been an age-old practice, and that comes with it. But what is more important, and like what we have discussed in this morning, is that changing climate, we need to note that it places an enhanced relevance of this climate information, and it's all the more important because of various issues connected to sustainability, and also dealing with the variations in climate which are increasingly difficult to understand. So making more effective use of climate information, and this, as we have seen, it has relevance to all the SDGs, DRR initiatives, and climate adaptation. So all that makes it important to have climate information in a proper way delivered for various climate smart practices, which we have heard this morning also. So we had some discussion about this range of climate phenomenon. If you see, there is a range of very small time scale events, and the earlier presentation, for example, the El Nino events fall under the seasonal time scale, and in between them we have different events which come and go at different time scales, and on the y-axis we have the lifetime of these kind of phenomena, weather and climate phenomena, and the x-axis is the size. So there is a connect which gives you a confidence at that particular time level and scale level, and the climate information will be generated. And then that also gives us this range of climate prediction, weather predictions, which we have access to nowadays. Like you have nowcast, we have short to medium range weather forecast, extended range forecast, which go up to 30 days, and then sub-seasonal to seasonal forecast, which goes from months to seasons, and then we have climate prediction and climate projections, which go from 10 years to projections which go up to 100 years. So all this kind of information, range of information is available, and they could be used, as we have seen, on various kind of decisions connected to agriculture sector, in terms of policy making, in terms of choices, in terms of agronomic decisions at farmer level, and also at a national level on strategic basis and long-term planning decisions. So you have a scale of information available, and the fact is that each of them come with some level of uncertainty, and as you move, it's a strategy to use less uncertain information to give you alerts and start some kind of preparedness priorities, and then go on to response stage when we are more sure about. And this is the strategy which we used for building this system, which I'm going to talk about. So at one end we have these very highly complex weather and climate models, which gives us a lot of information on the different time and space scales. And then we have a whole lot of research required, and there are some tools, and in the morning presentations we saw that they are all mostly yield and production oriented, and there is a lot of more requirement in terms of understanding the climate impacts on livestock, pests and diseases, and so on. So this is a matter of a domain which is an interface, which is basically the research needs to fill these gaps so that this become operational and they are used by the end users. At an end user level, we have various activities. For example, this is one of the activity which happens every season in about 20 countries in Southeast Asia and South Asia, which RIMES as an agency is supporting, and these are called monsoon forums or national climate outlook forums. So there, the seasonal forecast with all its uncertainties are shared by the respective meteorological services, and they are interpreted, and all the stakeholders from different sectors are present there, including agriculture, and they try to understand the uncertainties and try to interpret it on how best it can be used. So that is one of the processes which enables this kind of a connect, and it also feeds back to what kind of research is required, and also what kind of betterments are expected by the sectors. And we also have at a community level farmers climate field schools, which inform the farmers on what kind of climate information is available, and also generally try to build the awareness among farmers. And these practices are very, they have been going for several years in some of the countries. And the various sector departments which come and participate in the National Monsoon Outlook Forum, they provide feedback on the kind of systems they need. And this system, which I'm going to show in the next slide, is one of the systems which came as a requirement from the monsoon fora in Myanmar. So in terms of tasks, integrating a lot of data, maximizing the utilization of observations, and using them in conjunction with forecasts, and producing some climate and weather information which is useful. So our two prototype systems, where one was targeted in Myanmar's dry zone. This is the central area of Myanmar. It's east of India. And then there was the other one which was in the southern Indian area on one of the districts of a state called Tamil Nadu. So in these two states, we developed this prototype system. So I'll talk more about the Myanmar system, which has been operational for about 2 years now. And basically, RIMES has been working with the Department of Meteorology and Hydrology since 2009 with the National Monsoon Forum. And then improvements in agromet services has been priority, which has come up from the institutional discussions. And the project was supported by UNSCAP to start with, and then under the broader capacity development project. And then there was also a set of agromet observatories were installed within this project, and the main aim of the system was to develop agromet bulletins. So this is the area where this project was located in two provinces of within the dry zone of Myanmar, and this is Niamu and Muniva in the center. And then these are both very low rainfall, variable rainfall and high temperature areas. So this is where they wanted to pilot the prototype. So the system itself is a web-based system called Session. It's got an acronym, and it's a web-based system which is customized for these two areas which I just mentioned. And there are two weather model input data sets which are coming into it operationally. One is the ECMWF deterministic forecast for 10 days through an arrangement, collaborative arrangement with ECMWF. And then one of the popular weather research forecasting system, mesoscale model, which is being run at RIMES at 3 daily time. So these are the two model data inputs on the weather, both medium time range and the short time range currently being used. So these two data sets are ingested automatically on an operational basis, and then the project was with a lot of cooperation from both the Meteorological Department of Myanmar and the Agriculture Department of Myanmar. All these, both these institutions were very closely involved with the system. So I don't go into all the details of the system, but it's got three streams of data. One was the climate information part, that is the weather part. So it's got both weather and the future part, which will include monthly outlooks as well as seasonal outlooks. And then we have the observed part, which is the observations coming back as a feed later from the meteorological office. So this is used for monitoring statistics and also verification processes. And then we have a whole lot of static layers, which is to connect it with particular locations, soil type and so on, crop type and agroecological characteristics and so on. So all this is combined on the web-based system, and also it has the localized crop weather calendar on what crops are grown and what weeks are more, what 10-day periods are more sensitive in terms of requirements of meteorological parameters in their weather forecast. So this is a part of, and then there is a custom crop advisory and various other databases, and this system can ingest and then make decisions based on this crop calendar on what kind of climate information is required for that particular area on that particular 10-day period. So this can generate, the bulletins generated will be examined by the meteorological services, and once they are okay with it, then it is pushed to the respective agriculture department officials, that is the extension workers in the areas, two pilot areas, and also some progressive farmers in a systematic way. So there are various options here, like you can do a SMS or just go as a bulletin or even through social media. So this is a screenshot of the system, which is called Specialized Expert System for Agroecological Early Warning, SESIME, and it's got various panels, and it's the way the data is rendered and a landing page. So the details which are there in the system is the overview or the dashboard which you just saw, and then the advisory, which is the bulletin which is formulated by the system and presented to the department officials, both the meteorological department as well as the agriculture department. Then they have the data panel, and then the climate monitoring panel. So all these are part of the system. So in the data and modeling crop data parameter, we have we chose some of the crops which are very popular in those two areas, which were paddy, sesame, pigeon pea, cotton, and chili groundnut. So for all these 6 crops, through farmer field schools and the local involvement of the agriculture extension officials, all the details about the crops were collected, and it forms a part of the lookup table inside the system. And this can be updated through an interactive process. So this is again the weather part, which involves the model data from 2 different models. One of them is a more coarser resolution model, and it's got a lesser level of confidence, but it gives a 10-day lead period. So it allows you to prepare in some ways. And then the 3-day model is more accurate and of a higher resolution. So the system then allows you to create advisories, and this could be examined by the officials who are given access to the system, and they can decide on how to modify it if they want it modified with their own corrections or any other extra inputs. So the system is scalable in terms of more crops and location information can be added, and then the crop data can be made more sophisticated in terms of you can use results from model sensitivity studies to calibrate and plug in more details, and then observation data can be uploaded into the system, and also some satellite imagery if required. So this also is another part of the data panel which adds receivers. For example, you can add who are the agriculture experts who would have access to the system, who would be the farmers and other database where the agriculture extension workers to whom the information will be going as SMS text, as bulletins. So various processes are possible in terms of giving access to users of the or dissemination. So this is most of what the system is about. So the levels at which the operationalization works actually is the very close involvement of Department of Agriculture and the Meteorological Department, and at the township level we have the involvement of agriculture extension workers, and then there has to be a coordination at provincial and divisional level. And then at a national level, the departments, the 2 main departments, and then we saw to it that the system is of a level of complexity which is easily assimilated within the process which was already going on, and then it remains scalable at a later stage with more complicated or more sophisticated work. So this is a slide about the monsoon forums, which are basically processes where the multi-stakeholder engagement takes place, and that is where these ideas and requirements for what kind of support is required is asked from the meteorological services. So these are currently we are doing in Bangladesh, Bhutan, Myanmar, Maldives, Nepal, Pakistan, and Sri Lanka. It's a part of a larger effort being supported under the WMO GFCS project, a global framework for climate services for the South Asia region. So it's part of that initiative, and to look at a checklist for an operational setup to happen is, of course, we need location specific and requirement oriented, so it has to be very bottom up in terms of requirement and formulation of the information required and how they are going to use it and all that. Then it has to build on existing capacity and evolve gradually, and bring in sophistication as steady capacity development will be also part of the scaling up process. And the pilot locations, currently there are only 2 pilot locations, but it is scalable for a larger area because the data is available and it can be easily done. So in that way, the system is built to be easily upgraded. And then, of course, as I said, most of this, there needs to be involvement of the extension workers and the workers at a level where the community get influenced. So there could be innovative dissemination system. For example, one of the locations, they wanted the whole thing to be rendered over a Facebook kind of platform. So that is also possible within the system to easily do it. So that's about last slide. So identifying how climate information is generated and shared. This is in a general context, it is very much required to understand the context and then identify gaps. Of course, there are a lot of gaps in most of the places where we work. Observational data, operational linkages, information sharing, standards, and research support. So demonstration projects serve as a good place to start, and we can ensure long-term sustainability if the right institutions support. Thank you very much.